This is the help video for the mid-unit 6 quiz. Let's take a look at this here. Practice ALEKS questions. So it says for each of the following quadrilaterals, select all the properties that must be true. The easiest way to do this is to actually draw these out so it's easy to spot. So I have a parallelogram. I have a rhombus, which is a parallelogram with equal sides, and we have a rectangle. Now, once you have a little sketch of each, it's pretty easy to answer these questions. Does a parallelogram have only one pair of parallel sides? No, it doesn't. It has two pair of parallel sides. It does not have right angles. It does not have all sides congruent. A rhombus also has two parallel sides, and it does not have four right angles in the corner, but it does have all congruent sides. A rectangle also has two pairs of parallel sides, and it has four right angles in the corner, but of course it does not have all congruent sides because it has a longer set and a shorter set. So the easiest way to do that one is to draw a picture. Given the marked information on the figures below, classify it as a parallelogram or not necessarily parallelogram. Note that each figure is drawn like a parallelogram. So you should not rely on the figure drawn to determine your answer. Keep in mind what makes a parallelogram. That is OCD. Opposite sides are parallel. Opposite sides congruent, opposite angles congruent, consecutive, keep spelling that. Angles are supplementary. Supplementary, and the fact that the diagonals bisect each other. Now, with that list, there is one more additional one, and it is if you have the same set of sides that are both congruent and parallel. That's number 6. Okay, 1, 2, 3, 4, 5, 6. So keeping that list in mind, we do this. Here on the left, just kind of make a mental note of what you have. You have one set of parallel lines, one set of congruent lines. Now it looks like it fulfills this last one, but it's not the same set. And so what you have actually here is parallel lines. And the other side congruent, that's a trapezoid, isosceles trapezoid to be specific. Taking a look here, we have, it looks like double sweep, no, that's a match, hang on. Okay, one set, which means you have alternate interior angles congruent, which makes those lines parallel. Double set, armpits of the Z, which will make these guys also parallel. So this one is a yes. This one was a no, not necessarily a parallelogram. Taking a look here. Two sets of sides congruent, however, they're not opposite. What is this? This is a kite. So that one is a no. And take a look here. This one's probably one of the trickier ones. Like, ooh, yes, we have parallel lines. That's a maybe. Then look here, you have armpits of the Z, but the armpits of the Z are for the same set of parallel lines. That is a no here. What we have here is a trapezoid with armpits of the Z. And since it's only One set of sides parallel, it is a trapezoid. It says below the figure is a rhombus. Find all the measures, really simple. A rhombus bisects corners here. The rhombus bisects the corners, and the key to many problems is there's also a right angle. So you could just walk this over 53, 53, 53, 53. That's going to be 3, 53, 53. And then, of course, because of the right angle, you know that this adds up to 180. So 90, 53 minus 90. Actually, it's the other way around, technically. Seven, and then armpits of the Z, 30, 37. Taking a look here, it says, how do you find you have the sum of the interior angles of a convex polygon is 1260. A couple clues here. The fact that it uses the generic polygon means the n is the unknown here. You ask yourself interior, exterior, and there it is. Sum or 1, there it is. So you have the sum of interior angles, sides minus 2 times 180. Sum interior angles, sides minus 2 times 180. You do not know the n, so this number does not go there. It goes over here because that's what it is, the sum of the interior angles. Two ways you could do this. You could either distribute the 180 or you can divide the 180 out completely. I'm going to do that. 12, 180, goodbye zeros. I'm going to divide both of these by 2. I'm going to get 9. Divide by 2, that's going to be 6 goes in there, and then 3. So 9 divided by 63, I get 7. You're not done. And minus 2. Plus 2, plus 2, n is 9. So it is a nonagon. Said the measure of each interior angle of a regular polygon is 150. That is an equal sign. Again, poly means you don't know the n. And we are now dealing with a single interior polygon. So 1 each angle interior. That's going to be sum over sides, n minus 2 times 180 over n. 150 is going to go over here. 150 equals n minus 2 times 180. Over n. Oh, hang tight. You didn't see the cross multiplication, so I'm just going to do this. Cross, multiply, and distribute. So I get 150 n equals 180 n minus 360. And 3 goes into 36 12 times. So it is a 12-gon. Right here, it says in a rectangle below, BD is 6x minus 4, AE is 10, and the measure of ECB is 59. Now, it's going to tell you to find specific things, but my recommendation is just find everything possible and then just pick off what it asks for. Don't ever focus just on what it wants you to find. Just find everything possible, which we're going to do right now. So B to D is the whole side. AE is 10. And ECB, make sure you trace that very carefully. ECB, right there, is 59. Okay, we're going to go for the angles first because they are the easiest, in my opinion. So it's a rectangle, right angles. And because it's a midpoint and the length of these are exactly the same going both directions, all four of these pieces are equal, making this an isosceles triangle. Two equal sides, two equal angles. So we have the 59, 59. Armpits at the C, like this. 59, 59. Yeah, I'm going to take away from 90 degrees. It's going to get us 90 minus 59. 31, 31. Armpits of the C. Bring this down, 31, 31. And then we find the middle angles. Exterior sum, remote interior. So that makes this right here 62, 62, 118, 118. There. Now we got all the angles. And you ask yourself, what is the relationship between the red and the blue? Well, we know one red equals two blues in this case. So one red, which is 6x minus 4 equals 10 plus 10, 20. 6x minus 4. You solve from there. We have 6x equals 24. Of course, x equals 4. Plug it in. Always double check that. 6 times 4 minus 4. That's 24 minus 4. 20, which is double of everything. Okay, now you go back and you just ask yourself, what did it ask for? Well, it asked for x, which we have right here. Check. Ta-da! And it asks for E, B, A. E, B, A. So just very carefully, E, B, A. And it is 31. Okay, be very, very, very careful. This is it's not a difficult problem, but it takes a lot of steps. And I'll give you a couple tricks. You're going to be given some sort of quadrilateral, PQRST with the vertices. I recommend you write these vertices down with the numbers where they belong, right on the graph. Or if you're doing this freehand, make a quick sketch with these numbers. Okay. You're going to answer the following questions and determine if it is. So we're told it is if the parallelogram. So we know it's at least a parallelogram, whether it's a rectangle, a rhombus, a square, or none of these. All right. So you're starting with the fact that it is a parallelogram. We're going to find the slope of PS And then adjacent. Adjacent means next to. And so it doesn't matter which way we go, as long as it's next to. I'm going to go this way. Set up a template. I recommend you set up a template. Y minus y over x minus x. So here we go, y minus y. Notice I do the arrows to help my eyeballs catch that correctly. There's 6, negative 6, and negative 1. Be very careful with my double negatives. Now I'm going to go PS, go the other direction. And y minus y, 1, 4, negative 6, 2. All right. Double negative makes a positive there. So that's going to be positive 4/5. Let's just do a visual check. That was the red. And yep, it is positive because it's going up from left to right. Sometimes it's nice to just do a quick little visual check. Let's double check this. This is going to be negative 5. And double negative makes a positive. And that's going to be negative 4. And double negative makes a positive. So your final answer is 5/4. Do a visual check. And yep, that's positive slope too. So they're both positive. Come over here. So now we're going to do the length of PS, length, and one adjacent. Again, it doesn't matter which way you go. Oops, let me keep my color straight here. This one was red. This one is blue. I always recommend you make a template. Ready? And pulling the numbers from up here. We go x minus x, negative 6, negative 1. Y minus y, negative 1 and 3. X minus x, negative 6, negative 2. Y minus y, negative 1 and 4. And you do the math. Double negative makes positive. That's going to be negative 5 squared, negative 4 squared. 25, 16. Root 41. Let's check over here. Double negative makes a positive. This is negative 16 squared plus negative 5 squared, also root 41. Okay, so this is what we have proven. 1, we have proven that these are not making right angles, because if they did, these up here, even though they're reciprocals of each other, they're not opposite reciprocals. One of these had to be negative, so there's no right angle. But you did prove that they are congruent. So it cannot be a rectangle because there's no right angles. Can't be a square because those slopes do not multiply to negative 1. But the adjacent sides are congruent, and we're already told it's a parallelogram. Therefore, check. It is a rhombus.